Okay, so we have talked about simplifying rational expressions, and we have talked about multiplying and dividing rational expressions, and now we are going to talk about adding and subtracting rational expressions. So this is a little bit different than multiplying and dividing. When we were multiplying and dividing, all we had to do was just factor and cancel, and then we could just mash everything back together. But not so with adding and subtracting. Just like with fractions, in order to add and subtract rational expressions, you must have a common denominator. I'm going to abbreviate that as common denom because you know what it means at this point. So if you're presented with an expression that already has common denominators, then that's awesome. It's less work that you have to worry about. And just like with fractions, you'll add rational expressions the same way, where if I had 1/5 plus 2/5, well, that would be 3/5. I only have to add the tops. Same thing with rational expressions. So in this case, my denominators are already common. 2x squared minus 7, 2x squared minus 7. Awesome. So all I have to do is worry about adding the numerators. 6 plus negative 3x minus 8. Well, the only two things I can combine here are positive 6 and negative 8. So I'm going to rewrite this as negative 3x minus 2 over 2x squared minus 7. And that's my answer. Super simple, right? Let's take a look at another example like that where I already have common denominators. 14x squared minus 8 and 14x squared minus 8. Splendid. I don't have to make any changes there. Instead, I just need to add together 9x squared plus 3 minus negative 3x squared plus 5. Be sure you watch these negatives. Okay, so minus a negative becomes plus a positive. So that's going to give me 9x squared plus 3x squared, 12x squared, and 3 and 5 plus 8 over 14x squared minus 8. Now we could simplify this and factor it. If I wanted to take out 4 and be left with x squared plus 2, and then I could take out 2 down here and be left with 7x squared minus 4, and then reduce this to get 2x squared, 2 times x squared plus 2 over 7x squared minus 4. That could be my answer, but beware. It's good practice to always simplify, but sometimes the SOL will not offer an answer in simplified form, so you want to be on the lookout for the unsimplified version. So for this question above, this is most likely what your answer choice would have been on the SOL. Annoying, I know, but that's okay. Just make sure if you simplify it all the way down, be aware that that might not be a choice and you have to go back to the unsimplified version. Okay, so moving on to what you will more than likely see instead. Not a silver platter problem like what I just gave you, where you've got the two denominators that are already common. What do we do if our rational expressions have different denominators? Oh my goodness, we have to do math. Oh, we have to modify the expressions to have common denominators. So in order to do that, we have to figure out what factors are missing from each of the denominator expressions and then multiply each by the missing parts. So what do I mean by that? We're going to factor out these denominators so we can see what we're missing. 2x squared minus 2x and 2x squared minus 6x. So I can factor out a 2x here, and I'll have x minus 1. And I can factor out a 2x here, and I'll have x minus 3. So both of my sides have 2 x's, but this side has an x minus 1 and this side has an x minus 3. So those are my missing parts respectively. This side is missing x minus 3 and this side is missing x minus 1. So I'm going to multiply both the top and the bottom by the missing parts. So I'll have x squared plus 2 times x minus 3. That's my missing part over here. 2x squared minus 2x times x minus 3. Okay, and then on this side, I've got 5x times my missing part of x minus 1. I don't have an x minus 1 over here. I've got it over here, so I need to add it over here. And then 2x squared minus 6x times x minus 1, my missing part. Excuse me. So we're going to rewrite that. Okay? We can multiply these things back out so that we can combine like terms. So we'll have x squared plus 2x minus 3x minus 6 plus 5x squared minus 5x. Now I've got a whole mess of like terms that we can combine. And we'll have that over 2x times x minus 1 times x minus 3, because that's our common denominator. All right, so if we're combining like terms, then we've got a 5x squared and an x squared, so that gives us 6x squared. Excuse me. And then I've got a 2x minus 3x, that gives me negative x minus 5x. Negative 1 minus 5 is negative 6, so that's negative 6x. And then my lone constant, minus 6, all over 2x times x minus 1 times x minus 3. So I left that in factored form so we could see all those pieces. This side has a 2x and an x minus 1. This side had that same 2x and an x minus 3. We had to multiply each side by that binomial that it was missing. So in the end, our common denominator was the 2x factor, the x minus 1 factor, and the x minus 3 factor. And that's our final answer. All right, we've got one more to try. This one looks like it's going to be a doozy. Okay, here we go. 6z plus 6z over 6z plus 1 minus 2z squared over 3z plus 4. We can't factor this out, right? There's no GCF we can take out. There's no factoring we can do. So each of these denominators is the other thing's missing part. So when we're multiplying both the top and bottom by the missing part, if I've got 6z over 6z plus 1, well, the missing part here is the other denominator. So I have to multiply it top and bottom. All right, and that means minus 2z squared over 3z plus 4. The other denominator is the missing part. So I'm going to multiply top and bottom that way. All right, so now we're going to multiply these things and rewrite it so that we can combine like terms. So I'm going to distribute 6z times 3z, is 18. I am really fighting this bronchitis, you guys. 18z squared, 6z times 4, 24z, minus 2z squared times 6z is going to give me 12z cubed plus 2z squared. Now, should this be a plus 2z squared, or is this subtraction sign going to carry through with the 2z to make this minus 2z squared? If we made this minus 12, we need to make that minus 2z squared also. Don't forget to carry over those signs. Okay? And then my common denominator, if I FOIL these things together, I get 18z squared plus 3z plus 24z plus 4. All right, so let's combine our like terms. 18z squared minus 2z squared, that's going to give me 16z squared, but I've got a cube, and I want to put that first because I want to go in descending order. So negative 12z cubed plus 16z squared plus 24z over 18z squared. 3z plus 24z is 27z plus 4. It's a lot of z's. So that's it, guys. When you are adding and subtracting rational expressions, you need to check and see what each side is missing. Factor out those denominators if you can. If you can't factor them, then that just means you're going to multiply one side by the other denominator and vice versa. If you can factor them, you're just going to multiply by the missing factors. So it just depends on what you've got going on, but you have to make common denominators if you are not handed a problem with common denominators already. So if this is confusing, pause, rewind, and rewatch. Otherwise, get your questions ready. We'll go over them in class, and we'll do lots of practice. And then solving rational equations is up next. You guys are doing a great job.